Welcome to MicroProcessor Microcontroller course. Today we are going to discuss 16-bit microprocessor 8086. The objective of this topic is to understand the architecture of 8086 16-bit processor. Before going to the subject, today's outline. Today we are going to discuss what is microprocessor, what is microcontroller, what is the difference between a microprocessor and a microcontroller, features of a 16-bit microprocessor, and architecture of 8086 microprocessor for flag register of 8086. Yes, first of all, go for what is a microprocessor. Yes, a microprocessor is an electronic component that is used by a computer to do its work. Next is the central processing unit on a single integrated chip containing millions of very small components including transistors, resistors and diodes that work together. Next, the microprocessor, also known as the central processing unit, is the brain of all computers and many household and electronic devices. Then, what is a microcontroller? A microcontroller is like a brain. It's a simple IC. Micro means small. Yes, small controllers suitable on a small chip. It's an era of technology. Everything getting smaller inside with a rapid performance that is achieved through the microcontrollers. It is designed as compact as possible. This is the part that we used in our embedded systems. Difference between a microprocessor and microcontroller. As I said, it's having only CPU in the chip, like most of the Intel processor having the CPU. Next, the chip that is dependent on the chip of many functions. This controller is also have RAM, ROM, and other peripherals like its CPU or processor. It is a single chip which contains, the computer has everything inbuilt. That is the difference between a processor and a controller. Now we are going to see the features of a 16-bit microprocessor 8086. Intel 8086 is a 16-bit microprocessor. We have seen the third generation of microprocessor. Before doing that, we know the evolution of microprocessor. First generation belongs to the 4-bit. Second generation belongs to 8-bit. Third generation belongs to 16-bit. Fourth generation 32-bit. And fifth generation now we are in a 64-bit. You know the recent microprocessor Intel i9, which is exclusive for the gaming purpose. It has a lot of transistors and it will perform as early as of more threads. Yes. Now we are seeing the third generation of microprocessor, which is a 16-bit microprocessor. So Intel 8086 has a 16-bit microprocessor. This 8086 has HMOS microprocessor and it has a 16-bit data bus and 20-bit address lines. It has generated a 16-bit of input-output address. Hence, it can access 2 power 16, that is 2 power n. So 16-bit, 2 power 16, totally 65,536 of input-output ports. Intel 8086 provides 14 16-bit registers. So these are the some features of 8086, followed by pin details. It has 8086, which has 40 pin dual in package, that is DIP, and it requires a power supply of 5 volt. It does not have an internal clock circuit, and 8284 clock generator is used to generate the required clock for 8086 microprocessor. The maximum internal clock of 8086 is 5 MHz. So it can operate in 2 modes. One is a minimum mode, another one is maximum mode. So the 8086 has 2 modes of operations, which is minimum mode operation and maximum mode operation. Next, it may support a multi-programming. That is, it may use for the multiple programming can access in a single processor. This is the kit we use in our lab. 16-bit microprocessor. You can see this is the kit by interfacing with the keyboard, which is giving a program in a assembly language so that the processor can convert the mnemonics and each instruction will be executed. Hope you will see this in our lab. Next, coming to the subject of architecture. Before going to the architecture, why we say it is a 16-bit microprocessor? We know that it works under the frequency of 5 MHz. Also, it has two more variables are there in the 16-bit, 80861 and 80862. These two may operate on a frequency of 8 MHz and 10 MHz of cycles. Now we are discussing the 5 MHz of cycle. Coming to the architecture, it has two major units. One is bus interface unit, another one is execution unit. Let us see, this part belongs to the bus interface unit and this part belongs to the execution unit. While in the exam, if they ask, write or draw the architecture of 8086, you have to draw the diagram and you have to explain each and every block. The same, if they ask what is the block diagram of 8086 or draw the block diagram of 8086, the same answer. You have to draw this block diagram, architecture diagram, and you have to explain each unit. Now, before going to the bus interface into execution unit, we should know how the architecture of 8086 microprocessor will get the input, how it may execute the instructions, and how it may even to the other peripherals. Yes, we may have the memory interface. For this processor, the input and output device, memory device and other peripheral device which will be connected to the port, which is called memory interface, which belongs to the bus interface unit. That's why the name is called bus interface unit. I told already this unit belongs to the bus interface unit, this unit belongs to the execution unit. So the name itself, the bus interface unit, belongs to interface the other memory devices and other input-output ports. We have get the data from these ports, and it will go to the 6-byte prefetch queue. So the bus interface unit having just connecting, getting the data from the other devices, and it may be passed to the execution unit. Here we have pipeline processing. The advantage of 8086 is pipeline processing, because at the time it may prefetch the instructions, it may execute the instruction and decode. In the first cycle, the instruction will be prefetched, and second cycle, the instruction should be decoded. At the same time, another instruction should be prefetched from the data, from the register. In third cycle, the instruction should be executed. At the time, another instruction should be decoded. This process is said to be pipeline process. So this architecture have a pipeline. So if first we get the data from the instructions queue, at the same time, the another instruction should be executed. So when executing, the another instruction should be prefetched from the instruction queue. First, we get the data from the input or output ports or memory devices, and the data should be passed through the 6-byte prefetch queue. From the 6-byte prefetch queue, the data will be passed to the execution unit. So in the execution unit, we may have ALU. So this ALU which performs the arithmetic and logical operations. So the data should be get from the instruction queue. The data will be calculated in the ALU. From this operation, some flags will be generated for getting the output. If 2 bits of data will be added, by adding these 2 bits, the carry will be generated. So the carry flag will be opened. Let us see the flag registers in the following slide. Before that, after performing the output, it may go to the flag registers. So after execute the operations, again the data will be passed through the segment registers and we move to the other devices. So processor which may have the register segment. So I told DIU and execution unit. So in DIU we may have instruction queue, segment registers and memory interface. In execution unit we may have control unit, ALU, operand, flags, general purpose registers, stack pointers and index registers. So the general purpose register is a very important one. In general purpose register there is a combination of two 8-bit data. Actually I told already in difference between the processor and the controller. It may have only the CPU. In CPU we have registers. The registers will act as a memory. There is no separate memory unit which will be available in the processors. So the advantage of this general purpose register is to store the data, to access the data. Again it will be moved to that. Similarly, for example, we have segment registers. What is the role of the segment registers in the bus interface unit? For example, take a book. In the book we have the 500 pages. If you want to take a particular topic, as well as architecture of 8086, if you want to take the architecture of 8086, we should directly go to the chapter 1. So it is very easy for us to search in chapter 1. Without separating these chapters, it is very tough to identify or to find out the particular topics. That's why the microprocessor have the 4 segment registers which is easily fetch the data to the making the process. If in a single memory it is very difficult to access. So that's why we may make it into a segment like control code segment, stack segment, data segment and extra segment. Followed with the segment registers, we have instruction pointer. Similarly, the general purpose registers. Here we may have two 8-bit identical AX, which is the combination of AL and AH. Similarly, BX, which is the combination of BL and BH. Similarly, CH, which is combination of CL and CH. Next, data, combination of DL and DH. DL belongs to 8-bit, DL belongs to 8-bit, totally 16-bit. So the processor, 16-bit processor have a 16-bit input which will be performed and getting the 16-bit output. For example, if you take 8-bit, then one of the register may act, that is AL or AH. So the general purpose register is the combination of two 8-bit registers, which is nothing but AX is nothing but accumulator, BX is nothing but base, CX is nothing but count, D for data. Okay, these registers will be used. Followed with stack pointer, base pointer, source index, destination index. So the data should be taken from the general purpose registers and it may be connected with the ALU and you perform the operations. The output will be given and it should be directly passed through the segment registers from the get out from the processor. This is the port where the data come from memory or output devices or other peripheral devices. We have a physical address. Here we have a 20-bit address lines. So 2 power 20, we have 1024 MB, that is the KB, which is nothing but 1 MB of data. So forward we have segment registers like code segment, stack segment, data segment and extra segment. Each segment registers which will be connected with pointers. The code segment have instruction pointer, stack segment have stack pointer, data segment have source index, extra segment have destination index. So the physical address, how do you calculate the physical address of the data? I said it is a 20-bit address lines. So each physical address is combination of a segment address plus offset address. How do you calculate the physical address? Each segment address which can be multiple of hexadecimal value like NH and added with our offset address. By calculating this, we may get a physical address which is nothing but an effective address. So this address helps to locate the data to the other devices. Yes. Followed with a flag registers. you have to see the flag registers. In 8086, we have a 6 conditional flag and 3 control flags. See this diagram. Totally have 16 bit. 0 bit carries have a carry flag. Similarly, second bit having a parity flag. Fourth bit having an auxiliary carry flag. 6th bit carrying a 0 flag. 7th bit carrying a sign flag. Similarly, 12th bit having the overflow flag. These 6 flags belongs to the conditional flag. These flags are also compatible with the 8085 8-bit processor. So this may happen for when it will come, this flag will be generated. By adding the 2 bit of data, if we have a carry, if the carry is generated, the carry flag is enabled. In previous slides we discussed, after performing the ALU, the operands and flags are there. So at the time, the flags will be enabled. We should importantly know about the conditional flag. Also we have 3 control flags like trap flag, interrupt flag and direction flag. This content is enough to explain the architecture of 8086 16-bit microprocessor, right? So what the outcome of this topic, architecture. So now we can able to understand what are the blocks, what are the units which are available in the 8086 16-bit microprocessor. So you can able to learn a ARM processor or ARM controller. Hope this content may helpful to recollect your architecture of 8086. Yes, thank you for all. In the next video, we will discuss that the 8-bit microcontroller 8051, right? Architecture of 8051. We will see